You're listening to the Quantum Space Podcast, Innovating Trust. This is episode 4 and is titled Understanding Edge AI, Revolutionizing Industrial Intelligence. Today, we are exploring the emergence of Edge AI, its technical foundations, market opportunities, and the players shaping its ecosystem. Based on a 3-part editorial series from the Quantum Space, we hope to provide insights for industries, policymakers, and technology leaders navigating the shift of intelligence from the cloud to the edge. This is Understanding Edge AI, Revolutionizing Industrial Intelligence.
You know, when you think about artificial intelligence, your mind probably goes straight to these massive data centers, right? Supercomputers humming away in the cloud, just tirelessly crunching endless amounts of information. It feels like this distant, powerful brain. But what if I told you there's this whole other universe of AI emerging, one that's much closer than you think, living right on the actual devices and machines that power our world? Today, we're doing a deep dive into Edge AI. It's really a revolutionary shift that's bringing intelligence right to the very place where data is generated. So our mission here is simple. Quickly get you up to speed on what Edge AI actually is, why it's becoming, indispensable, really, for industries, from manufacturing all the way to healthcare. We'll also look at the huge market opportunity it represents and, who the key players are that are shaping this new frontier. Think of it as a shortcut to understanding one of the most impactful tech shifts happening right now.
Yeah, and what's truly fascinating here is how it contrasts with the last decade. Cloud AI has been all about centralizing processing power, right? But Edge AI, it's fundamentally a response to the practical physical limits, things like latency, the need for constant connectivity, and critically privacy concerns. These are things that real-world industrial operations just cannot ignore. So this isn't just some minor upgrade. It really is a paradigm shift in how we even think about intelligent systems.
Yeah.
It's pushing computation out to where it makes an immediate, tangible difference, often in situations where, honestly, cloud solutions just aren't feasible. They're fundamentally impossible sometimes.
Okay, so if the cloud has been our go-to for so long, what's the fundamental change here? How does Edge AI actually work differently when it comes to processing data? We're talking about moving intelligence right to the edge of the network. So think devices embedded right in factory floors or on oil rigs, power substations, maybe smart cameras, autonomous robots.
Exactly. It's right where the action is.
And it typically follows a sort of 4-step process. First, you've got data capture. The devices gather signals from their environment, maybe vibration, temperature, video feeds, that kind of thing.
Mm-hmm.
Second, pre-processing. Right there on the device itself, there's local filtering and what they call feature extraction.
Right. Pulling out the important bits.
Yeah, think of it like tidying up the raw data and just pulling out the most important characteristics, those features that the AI model really needs. It makes the whole process much more efficient. Then third, model inference. This is where the AI model, which is already trained and ready to go, actually applies its intelligence on the device. It makes predictions, identifies anomalies, or recognizes patterns without needing to send all that data back to the cloud first.
Which is the key part.
Exactly. And finally, action and reporting. The system takes immediate action like stopping a machine or sending an alert, but it only transmits the essential insights upstream, not the mountains of raw data. And, what's making all this possible now is the incredible advances in hardware. We're seeing these specialized accelerators pop up.
Yeah, the silicon is catching up.
Totally. Like NVIDIA's Jetson modules, Google's Coral Edge TPU, that's a tensor processing unit, right? Custom built for AI workloads.
Right, specifically for this kind of job.
And Intel's Movidius VPU, their vision processing unit, these are all designed to run pretty complex AI models, but within tight power and heat limits right there on the device.
Indeed. And the immediate impact on performance is, it's obvious, but it's also about solving these real-world impossibilities, things that just couldn't be done before. For industries, Edge AI isn't just about technical feasibility. It's about fundamentally enabling applications that cloud AI simply cannot handle. And here's the surprising truth. Even with super-fast 5G networks, the basic physics of light, the time it takes for a signal to travel across continents, means cloud AI will always be too slow for truly mission-critical tasks.
Ah, okay.
Like those autonomous industrial robots we mentioned or self-driving cars. Edge AI isn't just faster, it's often the only way these applications can exist safely and reliably. That's the speed and latency reduction benefit.
Right. So that example of the robot arm welding a car chassis.
Exactly. Imagine if a fault occurs. The system has to react instantly. Delay of even half a second waiting for some cloud analysis. That could cause a defect, damage expensive machinery, or worse, create a serious safety hazard.
Yeah, makes sense.
And beyond speed, there's the lower bandwidth and cost. Instead of constantly streaming terabytes of raw sensor data, Edge AI filters out the noise locally. Take a smart security camera, for example. It might process 24 hours of footage right there on the camera,
Okay.
but only uploads, say, 10 minutes that actually contain detected anomalies. That saves massive amounts of bandwidth.
And the associated costs, I imagine.
And the cost, absolutely. Plus, think about environments with unstable or maybe no network infrastructure at all. Remote mines, offshore oil rigs, rural farms.
Yeah, connectivity is a big issue there.
It is. So reliability in low connectivity environments is crucial. Edge AI makes sure these systems keep functioning, even when they're completely disconnected from the cloud. Then there's data privacy and security. And the really interesting thing here is that privacy, which was often seen as a hurdle for using data, is actually becoming a catalyst for this whole new decentralized AI architecture.
Interesting twist.
Yeah. For sensitive data, like patient vitals in healthcare, doing the analysis right on the device ensures compliance with regulations like GDPR. The data doesn't even need to leave the local environment.
Right, keeping it secure.
And you touched on it, less data transmission and less central processing also means a smaller carbon footprint. That's increasingly important for companies focusing on their ESG targets.
That really does underscore what a transformative technology this is. But like anything, even game changers face, significant hurdles.
Oh, absolutely. It's not all smooth sailing.
We're talking about hardware constraints, right?
Right.
Finding that perfect balance of size, cost, power consumption, and heat dissipation for every single unique application, that's tough.
Very tough.
Then there's the sheer logistical challenge of scalability and management. Imagine trying to manage potentially thousands, maybe even millions of devices spread out everywhere. How do you securely update the AI models across a whole distributed fleet like that?
Like a huge operational challenge.
And of course, these edge devices themselves become attractive new targets for security threats. Plus, you've got interoperability issues in what's still, let's be honest, a pretty fragmented ecosystem.
And it's maybe worth just briefly diving into why these are such formidable barriers. Like that model optimization you mentioned.
Yeah.
It's this incredibly delicate dance. You're trying to maintain the accuracy of these complex AI models while simultaneously shrinking them down, pruning them to run efficiently on a tiny, low-power chip. That requires really deep expertise in both AI and embedded systems, which is a rare combination.
Right. Not easy to find those skills.
Exactly. And that logistical headache of securely updating and managing models across potentially thousands of devices, that is indeed a monumental task, not to mention the paramount security risks of putting intelligence right on the front line of operations.
So, given all these complexities, you might wonder if Edge AI is just setting itself up as a competitor to cloud AI. Is it one or the other?
That's a common misconception, actually.
Right.
But here's the critical thing to understand. It's generally not a replacement. It's a really powerful complement.
Ah, okay. Working together.
Precisely. The cloud is still invaluable for things like training those really large-scale AI models, aggregating insights from multiple sites, coordinating updates across the fleet. The edge, by contrast, is where the real-time inference happens. It provides those instant on-site responses.
So it's like different tiers of intelligence.
Exactly. Think of it as a tiered system. The edge handles the immediate local intelligence, the quick reactions, while the cloud provides the big-picture analytics, the long-term learning, and the global coordination. This hybrid model, edge plus cloud, is rapidly becoming the standard approach, especially for industrial IoT, but really beyond that too.
Okay, that makes a lot of sense. So with all these compelling benefits, the hybrid model emerging, how is the market actually responding to Edge AI? Is this really becoming a significant economic force, or is it still more of a niche technology?
Oh, it's absolutely a significant economic force already, no question. The global market for Edge AI is currently valued at, get that, somewhere around $20 to $25 billion in 2024.
Wow, okay.
And the forecasts, they project it surpassing $100 billion by 2030.
That's incredible growth.
It really is. That kind of projected growth is truly indicative of a fundamental shift happening. Right now, the most fertile ground is definitely industrial IoT and manufacturing. That's where Edge AI is driving things like predictive maintenance, figuring out when a machine might fail before it happens.
Right, saves a lot of downtime.
Huge savings. Also, quality control, using AI-enabled cameras on the production line and enabling smarter collaborative robots or cobots. The ROI there is crystal clear. Less downtime, higher yield, improved safety.
Makes sense. Where else is it taking hold?
We're also seeing strong adoption in smart cities and infrastructure, things like optimizing traffic flow based on real-time conditions, or public safety applications where you're processing metadata locally instead of streaming endless privacy-invasive video feeds.
Ah, okay. More efficient and privacy-preserving.
Exactly. And in healthcare and medical devices, it's enabling things like on-device diagnostic imaging analysis, smarter wearables that process vitals locally, and portable testing equipment. This is critical for privacy in advanced economies, but also for connectivity in emerging regions where cloud access might be unreliable.
Those growth figures are just staggering. What do you think is really driving that accelerated adoption? And looking ahead, what are the sort of next frontiers for Edge AI? What new opportunities are just starting to bubble up?
Well, the driver is definitely that tangible ROI we talked about, coupled with the increasing need for real-time decision-making that simply wasn't possible before. And the future opportunities, they're even broader. Think about autonomous systems.
Self-driving cars, drones.
Exactly. They require absolutely split-second decision-making. Edge AI will be their backbone, processing sensor data locally without having to wait for cloud input. Even with 5G, the risks of relying solely on remote inference for critical safety applications are just, well, too high.
Yeah, you can't afford any delay there.
Not at all. Then there's energy and sustainability. It's not just about reducing energy waste passively. Edge AI will actively optimize energy use. Imagine microgrids balancing supply and demand in real time, locally, or smart algorithms running right on wind turbines or solar arrays to optimize their output based on immediate conditions.
Wow, that's proactive optimization.
It is. And for companies genuinely committed to their ESG targets, this offers a really measurable way to move towards a more sustainable future. It could fundamentally transform how energy is generated, distributed, and consumed. And we're even moving beyond just running pre-trained models or inference at the edge. The next big frontier is federated learning at the edge.
Okay, what's that?
This is a really revolutionary approach. It's about training AI models collaboratively across many different devices without ever exchanging the raw, sensitive data itself.
How does that work?
Imagine thousands of devices, say, in different hospitals, each learning from their local patient data. Then instead of sharing the data, they only share the updates or the learnings from their local models. These updates are then aggregated centrally to improve the global model.
So the data stays put, but the learning gets shared.
Precisely. It preserves privacy while still harnessing the collective intelligence of a vast, distributed data set. This is going to be a game changer for industries handling sensitive information, like healthcare, finance.
Huge implications there.
Massive. Ultimately, we're looking at the possibility of AI-defined factories and supply chains, where Edge AI could orchestrate entire production lines dynamically and enable hyperlocal optimization across complex supply chains in real time.
That sounds incredibly complex but powerful. Despite those incredible opportunities, though, we still need to acknowledge that the hurdles we mentioned earlier remain, right?
Absolutely. They don't just disappear.
Talent scarcity is still a big one. Finding people with that niche expertise in both AI modeling and embedded systems development.
Still a major bottleneck.
Then there's the fragmentation of standards. Multiple frameworks, competing hardware platforms. It creates challenges for widespread, seamless adoption.
Makes integration tricky.
And the upfront scalability costs. Deploying and managing potentially thousands of these edge devices can be daunting, especially for organizations just starting out, maybe still in the pilot stage.
Definitely. Those upfront costs and the operational complexity are significant barriers to entry for some. And for investors looking at this space, understanding how companies are tackling these challenges is really key.
Indeed. And it's no surprise, given the potential that venture capital is buzzing around edge AI startups, particularly those focusing on industrial IoT, energy, and healthcare applications where the ROI is clear.
Money's flowing in.
Yeah, and it's not just startups. The big cloud hyperscalers, AWS with Greengrass and Panorama, Microsoft with Azure IoT Edge, Google with its Coral TPU, they're all investing heavily to extend their cloud ecosystems right out to the edge. They want a piece of this action.
They see which way the wind is blowing.
Absolutely. And the chip makers, too. Companies like Qualcomm with their Snapdragon platforms, NVIDIA with the Jetson modules we mentioned, they're in this fierce race to produce the best specialized hardware for the edge.
A real hardware arms race.
It is. And all this activity, it signals that the market is really maturing. The focus is shifting less from just the tech itself and more towards tangible business outcomes like reducing machine downtime, improving product quality, or enhancing worker safety. So let's talk about the players defining this landscape. It's fascinating because for decades, the biggest trend in tech felt like consolidation, right? Especially in cloud AI dominated by a few giants.
Yeah, a handful of names dominated.
But Edge AI seems to flip that script. The real insight here, I think, is that for intelligence to truly spread out to the last mile, to every device, it requires this unprecedented level of, well, fragmented collaboration.
That's a good way to put it. Fragmented collaboration.
Yeah. No single tech giant, no matter how powerful, can possibly own the entire stack from the chip to the application. This makes it a truly diverse and competitive ecosystem. It sits right at the intersection of hardware, software, connectivity, and deep industrial integration.
It's a complex web.
It is. And the foundation really lies with the semiconductor leaders. They're providing the brains at the edge. You've got the giants like NVIDIA, Intel, Qualcomm.
The usual suspects in silicon.
Right. Plus foundational architects like ARM, whose designs are everywhere, and companies like NXP, Infineon, and STMicroelectronics, who are crucial in automotive and industrial sectors, really pushing the boundaries of power efficiency and specialized AI processing.
And focusing on safety and security, too, which is critical.
Absolutely. And you even have these agile startups like Halo and Mythic innovating furiously in this space, constantly trying to raise the bar for performance per watt.
Yeah, lots of innovation bubbling up.
But while these chips are critical, the cloud giants still play a central role, right? Mostly in orchestration and managing the lifecycle of these devices and models.
Exactly. They provide the management plane. AWS, through IoT Greengrass and AWS Panorama, effectively extends their cloud intelligence out to the edge devices. Microsoft Azure IoT Edge offers that seamless hybrid model, embedding intelligence in gateways or directly on devices, but keeping it synced with Azure services in the cloud.
Okay.
And Google Cloud really emphasizes that tight hardware-software integration with its edge TPU chips and the Coral devices built around them. Then you have the industrial and automation leaders. These are the companies that are the true integrators, embedding edge AI into real-world processes.
The ones actually using it on the factory floor.
Precisely. Companies like Siemens, integrating AI directly into their industrial control systems and digital twin platforms. ABB and Schneider Electric are deploying AI to optimize energy systems and complex automation workflows. Bosch has its whole AIoT strategy, applying edge AI across automotive, manufacturing, smart home, building technologies.
They're going all in.
They really are. And you've got Honeywell and Rockwell Automation enhancing monitoring and control, often in the legacy industrial infrastructure, bringing AI to older systems.
What about the startups in this integration space?
Yeah, definitely don't forget the startup innovators. Firms like Foghorn Systems, which focuses on delivering real-time intelligence specifically for industrial IoT settings, and companies like Edge Impulse, which are building platforms to make AI model deployment much more accessible, even for developers working with really resource-constrained edge devices.
It's clear this really isn't a one-company show. Far from it.
Precisely. And what's truly defining this whole ecosystem is the power of partnerships. Interdependence is really the name of the game here. Think of examples like NVIDIA and Siemens pairing up NVIDIA's GPU acceleration with Siemens' deep industrial automation expertise.
Right.
Or AWS and ABB collaborating to integrate AWS's cloud orchestration capabilities with ABB's industrial edge deployments on the factory floor. Or Google and ARM working together to optimize TensorFlow Lite, Google's AI framework, specifically for the millions of devices running on ARM-based processors.
So synergy is key.
Absolutely. No single company, no matter how big, can deliver the full promise of edge AI alone. It's a truly collaborative effort, and it's fundamentally redefining how technology ecosystems function, less monolithic, more networked.
This vibrant collaborative ecosystem is exactly what's driving Edge AI forward so quickly. It really proves that openness and the strength of the whole ecosystem can matter more than just the sheer size of any one player. It feels like we're building this new decentralized layer of industrial intelligence, one that's faster, leaner, more secure, and closer to the physical world.
I think this deep dive really shows us that Edge AI is much more than just another technology shift. It's a fundamental reorganization of the entire AI value chain. Intelligence is migrating, It's moving away from being solely centralized in distant cloud silos and becoming distributed across potentially billions of devices worldwide. It's becoming the very operating layer of modern industrial systems, effectively blending local real-time intelligence with global coordination from the cloud, pushing the boundaries of what's possible in the physical world.
And for you listening, this knowledge isn't just about understanding, a new tech buzzword. It's really about grasping a fundamental shift, a shift that impacts almost everything from how your groceries get stocked in the supermarket to how a city manages its traffic flow, how your personal data is protected on your own devices, and even how our energy grids can become more efficient and sustainable. So the final thought to leave you with is this. As intelligence gets closer and closer to where the action actually happens, what new possibilities truly emerge? What happens when every machine, every sensor, every device has its own localized brain, capable of instant action, but also coordinating with the global mind of the cloud, all while hopefully preserving our data privacy and helping our planet? What will you do, or what will we all do, with that kind of powerful distributed intelligence?
That was episode 4, Understanding Edge AI, revolutionizing industrial intelligence in our ongoing podcast series, Innovating Trust. If you would like a digital copy of the white paper we have been speaking about in this episode, please visit us at thequantumspace.org, and you can download a copy from the Resources tab in the navigation menu. This was Innovating Trust, a quantum space podcast, edited and produced by Crown Communications.